All right, guys, this is Algebra 2, 3.2.4. We're going to be talking about adding and subtracting rationals today. So, oops, all right, we're going to go ahead and take a look at the first problem. It's just going to take us and look at, well, how did we do this with addition and subtraction? So, of just regular old fraction. So you had a problem in your homework last time that had you do this. We say, well, we needed to get those common denominators, right? So we'd say, well, I had to multiply the 1/3 by 5 over 5, and I had to multiply the 2/3 by 3 over 3, and that gave me 5/15 plus 6/15, and I can add those to get 11/15. So all that always comes down to is we need to get the common denominator, because that tells us like what size of piece we're going to be having. And I can really only add things if I have the same size pieces, right? If these are a different size than like these, then I can't just add them up and say I have this much, because some of them are different sizes. So we got to size them all the same, and then we can combine and have one big fraction there. So that's effectively the rationale of trying behind why we have to do that. So let's try and take that idea, which views, and how can we apply that when we have these rational functions. So the first one that we're going to be looking at here is number 98. So what I want you to do is pause and try and do the same thing as we just did with the regular old numbers. See what happens here if you tried that same strategy, and then come back here. All right, so let's take a look at what happens. So this is, small, let me see it when I can see it better. 2x over x minus 1 plus 3 over x plus 5. Okay. All right, so a little bit messy because I was writing when I wasn't looking, but here we go. I probably want to say, well, this and this, so x minus 1 and x plus 5, what's the common denominator there? Well, I don't really know what it is, so it's probably just going to be this times this. So what I'm going to do is multiply this by x plus 5 over x plus 5, because that's a giant one, so it just doesn't do anything. Here is x minus 1 over x minus 1. Again, another giant one, so it doesn't do anything. All these giant ones are going to do is make this look different and make it look the way that I want. So when I multiply that out, here I will get 2x times x plus 5 over x plus 5 x minus 1 plus 3 times x minus 1 over x plus 5 x minus 1. So I have the common denominator, so I can join these as one big fraction. X plus 5 times x minus 1. And then I can just distribute this through and get 2x squared plus 10x. And over here I would get plus 3x minus 3. And then I could do some combining of some like terms and get 2x squared plus 13x minus 3 over x plus 5 x minus 1. So then, if possible, I would try and factor this top one and say, well, will that cancel with anything below it? This one's not going to factor, because if I take a look at it, I'd have 2 times -3 is -6. To multiply and get -6 and add and get 13, that's not going to be nice whole numbers, so we're going to not be able to do that, but we are going to be able to do that at times in the future, so watch out for that. So there we go, right? That is what I get when I added those two up. So if we take a look at number 99, we're going to try, well, here's that same idea, right? But here, right, I have the 3x plus 1 here and here, so I don't need to multiply this side by x minus 5 times 3x plus 1, because I already have the 3x plus 1. So all I need to do is multiply this left-hand side by x minus 5 over x minus 5. I got to do nothing to this right-hand side. So that's something that we want to kind of watch out for. So go ahead and pause, try A and B, and see what you get. Oh, and on these ones, you can do that simplifying, so do try and factor the atop and simplify if possible. All right. So I'll keep that up so I can copy it because it's fairly small when I make it on the not big picture. I'm going to have x over 3x plus 1 plus 2x squared minus 2 over x minus 5, 3x plus 1. Okay. So looking at this, like I mentioned earlier, I need to have these have the same bottoms. Well, they almost do. This one's just missing that x minus 5. So let's multiply x minus 5 over x minus 5 on this side. That's all that I got to do as far as getting common denominators. So I'm going to have, I'll go ahead and multiply those out, x squared minus 5x over x minus 5, 3x plus 1, plus 2x squared minus 2 over x minus 5, 3x plus 1. So now I can combine things and get one big old fraction here. So I'll have x squared and 2x squared is going to be 3x squared minus 5x minus 2 over x minus 5, 3x plus 1. Well, now can I factor that top? Well, if I do my x, 3 times negative 2 is going to be negative 6. Bottom is going to be a negative 5. So what multiplies to be negative 6 adds to be a negative 5. Well, it's going to be a negative 3. So what multiplies to be negative 6 adds to be negative 5. It's going to be negative 6 and positive 1. All right. So then if I do out my big box, I have 3x squared, and then a negative 2, and then I'll have a negative 6, and 1x. So I can pull out here a 3x, and I can pull out just a 1. And here I can pull out an x, and here I can pull out a negative 2. So that is going to factor into 3x plus 1 times x minus 2 over x minus 5 times 3x plus 1. So now those 3x plus 1s are going to cancel out. All I'm left with is x minus 2 over x minus 5. Okay. And once again, we do have those same domain restrictions. I would say, well, x cannot be 5 or negative 1/3. Okay. And there we go. Awesome. So let's take a look at the second one. I'm going to get some fresh paper here. So just hold on just a moment. Okay. So the second one, let's make it bigger so I can see it easier. I apologize. It's going to be 9 minus 3x over x plus 3, x minus 3. Plus 2x over x plus 3. So here, my bottoms both have the x plus 3, but this one here is missing the x minus 3. So that's all I need to add to it. So multiply this side by x minus 3 over x minus 3. Here's my giant 1. So what I end up with, we're here, nothing's going to change. So 9 minus 3x over x plus 3, x minus 3, plus, multiply those through, I'll get 2x squared minus 6x over x plus 3, x minus 3. So then if I combine all my like terms, I end up getting 2x squared minus 9x plus 9 over x plus 3, x minus 3. So can I factor the top? Let's try it out. 2 times 9 is going to be 18. Bottom is going to be negative 9. So I need to multiply to be 18, add to be negative 9. Well, that's going to be a negative 3 and a negative 6. So then when I do my box, I get 2x squared, 9, negative 3x, negative 6x. So I can pull out just an x here, and I can pull out a 3 here. It needs to be negative. Here I can pull out a 2x, and I can pull out a 3, and that also needs to be negative. So my top is going to factor into 2x minus 3 times x minus 3 over x plus 3, x minus 3, and then those x minus 3s are going to cancel out. So I'm left with just 2x minus 3 over x plus 3, and x cannot be equal to either a negative 3 or a positive 1. Sorry, or a positive 3. And there we go. Right? So that's effectively the process for us. Now let's hop back over here and take a look at problem number 100. So this is the kind of culmination here. So this one's really, really scary because on the bottoms, we got big old ugly trinomials on both of them. So we might say, well, I didn't have to multiply the left-hand side by this side's bottom over itself, and the right-hand side by this side's bottom over itself. Now that will work. It's going to be really, really nasty. So the hint is let's try and factor these first and see if there's things that are already common, but we just can't see it because it's not in that factored form. So that's how I'm going to recommend you approach it. So go ahead and pause, try that out, and then see what you can do to add those up. And then come back here and I will be going through it. All right, so let's get going here. So we got 2x minus 1 over 3x squared plus 13x plus 4 plus x plus 3 over x squared minus 3x minus 28. Okay, so first thing that I want to do is try and factor these. So tops, I'm good. Bottoms, I definitely want to try and factor it. So I'm going to do, I'll do it here on the margin so I have a little bit more room. 3 and 4 is 12. Bottom is going to be 13. So multiply to be 12, add to be 13. Well, that's going to be 12 and 1. So if I draw out the box, 3x squared, 4, and then 12x and 1x. I can pull out an x, I can pull out a 4, I can pull out a 3x, and I can pull out a 1. So that's going to turn into 2x minus 1 over 3x plus 1, x plus 4, plus x plus 3 over, let's factor this bottom part. So this one I can do with that shortcut method. So I need to say, hey, what's going to multiply to be a negative 28, add to be a negative 3. Well, that's going to be a negative 7 and a positive 4. So x minus 7 and x plus 4. So now I can say, well, right, so all I really need isn't the entire thing. I just need, this is missing the 3x plus 1, and this is missing the x minus 7. So all I need to do, multiply this side by 3x plus 1 over 3x plus 1, and this side by x minus 7 over x minus 7. Okay. So when we do that, we're going to get x minus 7 times 2x minus 1 plus x plus 3 times 3x plus 1. Then we're eventually going to get them all under one big old fraction. I'm going to skip a step because I can save myself a whole lot of writing if I do that. This now is x minus 7 times 3x plus 1 times x plus 4. Okay. So I don't want to leave it like that though, because I probably need to try and combine these, as ugly as that might seem. So I'm going to want to FOIL this out, and then combine some like terms. So if I FOIL that, I would get 2x squared minus x minus 14x plus 7. And here I would get positive 3x squared plus x plus 9x plus 3. So combining my like terms, 2 and 3 is 5x squareds. X, and so that's negative 15 and negative 14, negative 5x. And then I'm going to have a 7 and a 3 is going to be a plus 10. So I can do a greatest common factor here, and I can factor out a 5. I have 5 times x squared minus x plus 2. So does anything multiply to be 2, add to be a negative 1? Well, that's not going to happen, right? Because I can't get, the only way to multiplying it 2 is 2 and 1, and I can't get or negative 2 and negative 1, so that would give me either a negative 3 or a positive 3, so I can't do any of that factoring there, but that's okay. And the bottom I'm still going to have x minus 7 times 3x plus 1 times x plus 4. So that ends up being my final answer there. All right, so again, if you only got it to like that, or you at least got it there, we're doing fine. But this is where we ultimately would want to be able to try and get it to. So that's as simplified and as factored as we can. All right, and then the very final part here on part C, we'll go ahead and try that one out. So if you haven't yet, go ahead and try out the C. Again, factoring that is going to be very, very beneficial, so please, please, please do that. And then come back here. All right, so we're going to have 2 over x plus 4 minus 4x minus x squared over x squared minus 16. All right, so I want to try and factor everything as much as I can here. So to start off, this is as good as I'm going to be able to get it. But over here, I can do a greatest common factor of x and have x times 4 minus x. And then this is a difference of 2 perfect squares, so that would factor into x minus 4 and x plus 4. Okay, so I'm going to use that instead. Well, the x plus 4 is good. Well, over here I'm missing the x minus 4. But I noticed something here, right? This 4 minus x is super close to that x minus 4. So if I can cancel those out, I don't need to worry about trying to multiply stuff and make things bigger than they need, right? So I showed you a trick a few sections back on how we can deal with stuff which is just the exact opposite signs. I'm going to pull out a negative from this as well, and that's going to give me now a negative x on the outside, and then negative 4 plus x on the inside, then over x minus 4 times x plus 4. So now these are the same. They're written in a different order, but if I just rewrote this as x minus 4, then they're the same. They're going to cancel out. So all I really have is 2 over x plus 4 minus negative x over x plus 4. So now I already have my common denominators. So all I gotta do is, well, that's just 2 minus a negative is like plus. So 2 plus x 2 plus x over x plus 4. Now you might say, well, let's write it like x plus 2. Totally fine. They both are equivalent. One's just kind of a little bit more common way of writing it out. Right, and then again, restrictions, x couldn't be -4 or +4, and that's all I'm really seeing. Awesome. Okay, so with that, a little bit of notes here, or little is an understatement there. Just read through them. There's not much here that you should feel like you need to actually take down. But read through that just to kind of refresh you on all these different processes we've kind of gone over. Again, don't feel like you need to copy this down because you do not need to copy this down. Just read through it, refresh yourself on how all those processes work. All right, so homework-wise, we're going to be doing 102 through 109, so go ahead and start working on that, and I will talk to you next time.